Question number 10. A curve has the equation given, this one. Find the coordinates of the two stationary points. To find the stationary points, dy over dx should be equal to 0. And then by using this equation, we can find the x coordinate. And then this x coordinate will be plugged in curve equation to find y. So this is the procedure or the approach we will use to find the two stationary points. First we find the dy over dx. dy over dx is equal to derivative of y. So 9 is constant and derivative of 2x 1 over 2x minus 5, which is 2x minus 5 to the power of negative 1 with respect to dx plus 2 times x, so derivative of x minus derivative of 5 with respect to x, and this one equals to the 9, so negative 1 power, and derivative of 2x minus 1 to the power of negative 1 is 2x minus 5 to the power of negative 1 minus 1, and the derivative of inner function, which is 2x minus 5, so derivative of 2x minus 5 is 2, plus derivative of x, which is 1, so 2 times 1, and derivative of constant is 0, and this one equals to the negative 18 over 2x minus 5 to the power of 2, and this one is equal to plus 2, and this is the dy over dx. We have calculated the dy over dx and we will equate it with 0 to find the value of x. So negative 18 over 2x minus 5 whole square plus 2 equal to 0, and this one is equals to the 18 over 2x minus 5 whole square equals to 2, and this one is 9, and by cross multiplication we will have 9 equals to 2x minus 5 whole square. Okay, this one is equals to the 4x square minus 20x plus 25 is equals to 9, and this one is equals to 4x minus 20x plus 25 minus 9 equal to 0, and this one is equal to 4x minus 20x and then plus 16 equal to 0, and this one is equals to the x squared minus 5x plus 4 equal to 0. This is the quadratic equation. We can apply factorization in this case. So x squared minus 4x minus x plus 4 equal to 0, and this one is equals to the x common, x minus 4 minus 1 common, x minus 4 equal to 0, and we will have two factors, which one x minus 4 and x minus 1. So equating with 0, we will have x equals to 4 and x equals to 1. We have two x coordinate of the stationary point, and now we plug these x coordinate in given equation to find the y coordinate. So given equation is y over 9 over 2x minus 5 plus 2x minus 5. So first plug 4 in this equation, and we will have, so y equals to 9 over 2 times 4 minus 5 plus 2 times 4 minus 5, and this will equal to the 9 over 2 4s are 8, 8 minus 5 is 3, and this one is also 8 minus 5, and solving this we will have 3 plus 3, which is equal to 6. So we have y coordinate for the value of x is equal to 4. Now plug x equals to 1 in this equation. So y is equal to 9 over 2 times x, which is 1, minus 5 plus 2 times 1 minus 5. And this one is equals to 9 over 2 minus 5, which is negative 3, plus 2 minus 5. And this one is equals to the negative 3 minus 3, which is equals to the negative 6, which is y. So we can say that the stationary points are 4, 6, and second one is 1, negative 6. Negative 6. These are the stationary points. Okay. Now let's move to the part B, which says that the find second derivative of y with respect to x and hence determine the nature of each stationary point. We have calculated the stationary point, which are this one and this one. First we find the second derivative. So first derivative was this one. So I just write it. dy over dx is equals to the negative 18 over 2x minus 5 whole square minus 2 or plus 2. So we find second derivative of this function. So we will have second derivative is equals to negative 18 derivative of 2x minus 5 to the power of negative 2 with respect to dx and derivative of 2. The second derivative will be equals to the negative 18 times power, which is negative 2, and the power will decrease by 1, and then the derivative of inner function, which is 2, and the derivative of constant is 0. So we have second derivative dy over dx. Second derivative is equals to the 72 over 2x minus 5 whole cube. So this is the second derivative. Now we need to find the nature of each stationary point. So we will plug stationary point in second derivative equation. First we plug stationary point 4, 6. So for stationary point 4, 6, dy square over dx square, where x is equals to 4 because the x coordinate is 4, and 72 over 2 times 4, which is minus 5 whole cube, and this one is equal to the 72 over 8 minus 5, which is 3 cube, and this one is equal to 72 over 27. This one is greater than 0, so we can say that this point is minimum. Now for second stationary point, which is 1, negative 6, so for 1, negative 6, second derivative at x coordinate 1, we will have 72 over 2 times x, which is 1 in this case, minus 5 whole cube, and this one is equal to 72 divided by 2 minus 5, so negative 3 to the power of 3, and this one is equal to the 72 over 27 negative. So this one is less than 0, so we can say it maximum. We can say that minimum point is 4, 6, and maximum point is 1, negative 6. 1, negative 6. Now let's move to the part C. The curve C is transformed to the C1 using the translation of negative 3, 7. followed by the reflection in x-axis. Okay, C is transformed to the C1 using the translation of -37 and also by the reflection in x-axis. We need to find the maximum point of C1. If there is a reflection in x-axis, for example, now for example we have the curve like this one, and we can say that this is function y of x. Okay, and you can see that this curve has two stationary points, one this one and second one is this one, and this one is maxima and this one is minima. When the curve or any function undergo the reflection in x-axis, it will become like, and this one is f1 of x, and the maxima has been converted to the minima, and this minima has become maxima after undergoing the reflection in x-axis. So we can say that the maximum point of C1 will be the minima point in C. So due to reflection, maxima point in C1 will be minimum point in C. So we can say that M is minimum point of which is 4 comma 6, and this minimum point has gone through the translation followed by the reflection, and this point has gone through the translation which is -3 comma 7. So translation of -3 comma 7, this will become 4 minus 3 which is 1 and 6 plus 7 which is 13. This is the translation. M which was C 4 comma 6 in C curve as undergo the this translation which is -3 comma 7, so it will become 1 comma 13 in C1. Now the reflection in x-axis, so it y-axis has been changed. So after reflection in x-axis, m will be equals to 1 comma -13. So the maximum point in C1 is maximum point in C1 curve is 1 comma -13. Now let's move to the part find the equation of C1 in the form of y is equal to a over bx plus c plus dx plus e, where a, b, c, e are integers. So we have the c which is equation of c is y is equal to 9 over 2x minus 5 plus 2x minus 5, and we need to find the equation of C1, and C1 has been achieved by transforming the C in using the translation of -3 comma 7. If we call it f of x, so this function has been transformed into C1 by the translation using the translation of -3 comma 7. So this will become f of x, translation is -3, so it will be plus 3, and y-axis will remain same, so this one will be 7. If we plug x plus a in place of x, we will have 9 over 2 times x plus 3 minus 5 plus 2 times x means x plus 3 minus 5, and this will be equals to the 9 over 2x minus plus 6 minus 5 plus 2x plus 6 minus 5, and this will be equals to the 9 over 2x plus 1 plus 2x plus 1. Sorry, we forget the plus 7, so this will be plus 7, and this will be plus 7, and this will be plus 7, and this will be equals to 9 over 2x plus 1 plus 2x plus 8. So this one is equals to the x plus 3 plus 7, which has been translated by the translation of 3 comma 1. Now the reflection in x-axis. Now reflection in x-axis. So this function f of x plus 3 plus 7 will be multiplied by negative 1. So this will be equals to negative 9 over 2x plus 1 minus 2x minus 8. So this is the equation of C1, or you can say that this is f of x, f1 of x, or